we are going to be looking at formula of organic compounds. We are going to be looking at the different formulas that organic compounds have. We are going to be looking at the definition of each type of formulas. We are going to be looking at questions that can come out from formula of organic compounds, and trust me, it is going to be a very interesting session. Grab your notepads as we journey. Now, when it comes to formula of organic compounds, we have three major formulas. The first is the empirical formula. That is the first. Now you see, the empirical formula gives what the simplest ratio of the number of atoms present. Please take note. It gives what the simplest ratio of the number of atoms present. So now let's say a compound like this exists. Let's just assume we have C6H6. Writing the empirical formula, it will be what CH. The simplest ratio of the number of different atoms present. You see, the empirical formula does not give us the actual number of different atoms that is present in what a substance. It gives us what the simplest ratio. Now let's look at the molecular formula. The molecular formula is gotten from the relative molecular mass and the empirical formula. So actually, the molecular formula is gotten from the empirical formula. And what does it do? It shows us the actual number of what atoms present. The total. It gives us the total number of atoms present. The actual number of atoms present. The most useful type of formula is actually what? Is actually the molecular formula. It gives us the actual number of molecules that are present. Now let's look at the structural formula. It is the most detailed. It gives us the actual details of the arrangement of substance in a compound. So let's look at something like methane. Now looking at something like methane, the structural formula will be this. You see, it gives us more details. It allows us to know how our bonds are attached. It allows us to know how are they placed. It allows us to know the bond angle. It allows us to know the hybridization. And that is the work of what? That is the work of the structural formula. Now let's look at questions, UTME questions under this topic. Now they say a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Now, he said if the molar mass of the compound is 180, calculate the molecular formula. Now, what are we supposed to do here? In calculating, take notes. We are going to calculate the empirical formula before we get the molecular formula. You know, I told us when I was explaining the three types of formulas that we have, I was telling us that we are going to get the molecular formula from the empirical formula and the molar mass. Now let's get started. Now the first thing to do when solving questions like this is to divide the percentage composition by the mass of each compound. by the mass of each compound, of each atom, by the molar mass of each atom. That is the first thing to do. Now let's do that. We have what? 40 divided by, that is carbon, 12. We have 6.7 divided by, that is 1. And we have 53.3 divided by what? Divided by 16. Now using our calculator, 40 divided by 12, that will give us 3.33. 6.7 divided by 1 will give us 6.7, and 53.3 divided by 16 will give us 3.3. 3.33. Now what is the next thing you do? The next thing you do is that you divide the values you have gotten after performing the first step. You divide it by the lowest number available. Divide by the lowest number available. Now doing that, 3.33 divided by 3.33 divided by 3.33 divided by 3.33, that is, we are going to have 1 here, we are going to have 1 here, and 6.7 divided by 3.33, that is what? 2.01. That is just 2. So that means that the empirical formula will equals what? C H 2O. That is what? That is the empirical formula. Remember what I told us about the empirical formula? That it is what? That it is the lowest what? Lowest ratio. The lowest ratio available. It does not give us the actual number of what? The actual number of atoms. Now let's move on. We are going to use this also. I'm going to use this also. Please take notes of all that has been said. Very, very, very important. Very, very important. Let me write this up very well, because I want us to use this same slide for the to get the molecular formula. Now, getting the molecular formula, we equate all of this to what? To the molar mass given. So in this case, what are we going to do? C in big brackets H2O into bracket what? N is equals to what? Is equals to 1 AT. Now what else do? You multiply N by the what? By the molar mass of each atom. You multiply N by the molar mass of each atom. So with this we have what? 12N plus 2 times 1, 2. 2N. We are multiplying this 2 times this 1 times this N plus what? 16N is equals to what? Is equals to 1 AT. Now let's add everything together. 12 plus 2 plus 16, that is 30. That is 30N is equals to 180. N is equals to what? 180 divided by 30, that should give us 6. N is equals to 6. Now that we have gotten our N, we will now slot it in. So our molecular formula will now be C. Our N will now be what? 1 times N is N, so that will be 6 C6. Then here we'll take this 2 times this 6, H12, 1, our N here, that is 1 times 6, 6. So this is the molecular what? This is the molecular formula. Now let's look at another question again. Now here they said they've even given us the empirical formula here. What we just need to do is to calculate the molecular formula. Now remember this, RMM is equals to what? 2 times vapor density. RMM is equals to 2 times vapor density. So our RMM here will be equals to what? 2 times 39. That will be equals to what? 2 times 39. That is equals to 78. Using the same principle, CH into bracket N will give us what? 78. That is 12N plus N is equals to what? 78. That is 13N is equals to 78. Our N will be equals to 78 divided by 13. That is 6. So our molecular formula will now be what? Our molecular formula will be C6H6. Our final answer. Very simple. Option C. Now let's touch one more question. Okay, yeah, they've given us the molecular formula. They've given us the empirical formula and the vapor density, and we are asked to calculate the molecular formula. You can pause the video and attempt it on your own to see if you are fully mastered this topic. Now let's move. RMM is equals to 2 times vapor density. What is our vapor density? Our vapor density is 90, so that will be equals to 2 times 90. Our RMM is equals to what? 180. Now using the same principle, CH2O into bracket N is equals to 180. Slotting in, that will be 12N plus 2N plus 16N is equals to 180. Now 12 plus 2 plus 16, that gives us 30. 12 plus 2 plus 16, that is 30N. 30N is equals to 180. N is equals to what? N is equals to 6. That means that our molecular formula will be what? C6H. We have our H2 here, that is 2 times 6, C6 H12O6. And that is all on chemical formulas or formulas in organic chemistry. Thank you for watching. See you in the next video.